Haloalkanes and haloarenes. In haloalkanes and haloarenes, in this video we are going to see the preparation and the properties of haloalkanes and haloarenes. Here the table shows the bond length, bond enthalpy and polarity of bond between carbon fluorine, carbon chlorine, carbon bromine and carbon iodine. Bond length of carbon fluorine to carbon iodine increases due to the increase in the size of the halogen atom, and bond enthalpy decreases on moving from fluorine to iodine. As the bond length increases, the bond energy decreases. Shorter the bond, stronger will be the strength is the concept. And the polarity of the bond also decreases due to the increase in the length of the carbon halogen bond. Next one is methods of preparation of haloalkanes. How to prepare haloalkanes? The first method is from alcohol. How to convert alcohol into alkyl halides are by reacting with hydrogen halide, by reaction with the phosphorus halides like PCl3 and PCl5, by reaction with thionyl chloride. So by treatment of alcohol with hydrogen halogenating agents like hydrogen halide and phosphorus halides and thionyl halides gives haloalkanes. The first preparation of chloroethane with ethanol by treatment with anhydrous zinc chloride, that is Lucas reagent. What is Lucas reagent? Lucas reagent is the mixture of corn HCl and anhydrous zinc chloride is called Lucas reagent. Ethyl alcohol on treatment with the Lucas reagent gives a chloroethane or ethyl chloride. H and OH reacts, removed as H2O. Instead of OH and chlorine gets substituted. So conversion of alcohol into alkyl halide by treatment with Lucas reagent. What is Lucas reagent? Mixture of corn HCl and anhydrous zinc chloride is called Lucas reagent. Second method of preparation of alkyl halide or haloalkanes from tertiary butyl alcohol. Tertiary butyl alcohol or 3-degree alcohol or 2-methyl-2-propanol. Tertiary butyl alcohol and treatment with hydrogen iodide. The presence of potassium iodide and orthophosphoric acid, H and OH react, removed as H2O. The place of OH, iodine gets substituted, it forms tertiary butyl iodide. Here 1, 2, 3, 3-degree alkyl halide, 1, 2, 3, 2-methyl-2-iodopropane or tertiary butyl iodide. So reaction of hydrogen iodide with the tertiary butyl alcohol gives tertiary butyl iodide. In the order of reactivity of haloacids, with alcohol is hydrogen iodide, hydrogen bromide, hydrogen chloride. Hydrogen iodide reacts with alcohol more faster than hydrogen bromide and hydrogen chloride. The next one is the order of reactivity of alcohol with haloacid is tertiary, secondary and primary. 3-degree alcohol, 2-degree alcohol, 1-degree alcohol. So tertiary alcohol reacts more faster with halogen acids than secondary than primary. Next one is, the next preparation is reaction of alcohol with phosphorus halides, that is PCl5 and PCl3, PX5 and PX3. So the halogen may be different, but the valency is the 5 and phosphorus halides of valency 5 and phosphorus halides of valency 3. Now we are going to see ethyl alcohol with phosphorus pentachloride. Ethyl alcohol CH3CH2OH reaction with PCl5 phosphorus pentachloride. H, one of the hydrogen and chlorine reacts and removed as HCl. And another hydrogen here we can write, so PCl5 we can write PCl5, one of the hydrogen reacts with the chlorine, removed as HCl. The second hydrogen reacts with in the substituted instead of the alcoholic group and form ethyl chloride or chloroethane. The 2 chlorine over, the remaining is 3 chlorine and phosphorus and this oxygen forming phosphoryl chloride. So ethyl alcohol on reaction with the PCl5, it forms ethyl chloride, POCl3 and HCl. Next one is reaction of ethyl alcohol with PCl3. 3 molecules of ethyl alcohol reacts with the phosphorus trichloride, and the 3 chlorine gets substituted instead of this 3 alcohol, thereby it forms chloroethane. The remaining 3 hydrogen, 3 oxygen with 1 phosphorus, it forms phosphorus acid. So reaction of PCl5 with ethyl alcohol gives ethyl chloride, phosphoryl chloride and HCl. Reaction of PCl3 with ethyl alcohol gives ethyl chloride and phosphorus acid. This is reaction of alcohol with phosphorus halide. Next one is reaction of alcohol with thionyl chloride, SOCl2, in the presence of pyridine. So heterogeneous compound. The reaction of alcohol with thionyl chloride, in the presence of pyridine, here instead of OH and chlorine gets substituted, this SO and O reacts forming SO2. Hydrogen and another chlorine reacts to form HCl. Instead of OH, 1 chlorine, ethyl chloride, SO and O, SO2, hydrogen within the remaining 1 chlorine, it forms HCl. The reaction of ethyl alcohol with thionyl chloride in the presence of pyridine to form ethyl chloride and sulfur dioxide HCl is also known as Darson's halogenation. So name reaction, Darson's halogenation. Next one is, so these are all the methods. These are all the methods, the conversion of alcohol into haloalkanes. Now we are going to see how to convert alkenes into haloalkanes. Here it follows the Markovnikov rule. What is Markovnikov rule? Hydrogen goes to the least substituted, hydrogen goes to the more substituted and halogen goes to the least substituted. Hydrogen goes to the more substituted, halogen goes to the least substituted is called a Markovnikov product, that is found to be stable one. So for example, the propene when reacts with hydrogen bromide, hydrogen goes to the more substituted product and halogen goes to the least substituted product, results in the formation of bromoethane, haloalkane, by following Markovnikov rules. Next one is how to prepare haloalkanes from alkane. For example, the reaction, when methane reacts with chlorine in the presence of sunlight, it is a free radical reaction. Free radical substitution reaction gives mono, di, tri and poly substituted product. For example, methane reacts with chlorine in the presence of sunlight. And here the hydrogen and chlorine reacts, removed as hydrogen chloride. Instead of hydrogen, 1 chlorine gets substituted from methyl chloride or chloromethane. This again reacts with the chlorine, here it forms, and another chlorine gets substituted, thereby it forms CH2Cl2, another hydrogen chloride removed. From this it reacts with 1 more chlorine molecule. Here 1 more chlorine molecule gets substituted, 1 hydrogen is removed, 1 chlorine gets substituted, forms CHCl3. From this again it reacts with the chlorine. Here another hydrogen substituted by chlorine, thereby it forms carbon tetrachloride. So it is a continuous chain reaction, free radical substitution chain reaction forming the mixture of haloalkanes. Chloromethane, dichloromethane and chloroform and carbon tetrachloride is formed. So this one is reaction of alkanes with chlorine in the presence of sunlight. It forms a continuous chain reaction, various substituted haloalkanes. Next one is halogen exchange reaction. This reaction is called Finkstein reaction. Here the bromoethane when reacts with sodium iodide, chloro or bromoalkane on heating with the concentrated solution of sodium iodide in the presence of acetone, what takes place is sodium and bromine react, sodium bromide, and instead of bromine the iodine gets substituted, thereby it forms iodoethane, CH3CH2Br plus NaI in the presence of iodine. It forms sodium and bromine react, sodium bromide. So iodoethane is formed. Here this follows SN2 mechanism, nucleophilic substitution reaction 2, bimolecular reaction. So the rate of the reaction depends upon 2 steps. This one is called Finkstein reaction. Next one is Schwartz reaction, where here also the one of the Here also chlorobromoalkanes on heating with metallic fluorides like silver fluoride, antimony fluoride or mercury fluoride gives fluoroalkane. This reaction is called Schwarz reaction. CH3CH2Br plus silver fluoride on heating gives, here Ag plus Br reacts AgBr and fluorine gets substituted instead of bromine. It forms fluoroethane. So called Schwarz reaction, the formation of fluoride from other halides by using silver fluoride is called Schwarz reaction. Next one is Hunziker reaction, where silver salt of fatty acid reflects with bromine in the presence of carbon tetrachloride. It gives bromoethane. Ag plus Br reacts AgBr. This CO2 is removed as CO2. Instead of this group, here the bromine gets substituted. It forms bromoethane. It's called Hunziker reaction. Silver salt of fatty acids when reacts with halogen bromine, the presence of carbon tetrachlorides gives bromoethane. So another reaction of preparation of one type of halogen from other type of halogen. Next one is physical so we can sum up. So from alcohol on reaction with Lucas reagent and hydrogen iodide, the alcohol with the phosphorus halides like PCl5 and PCl3, the reaction of the Darcy's reaction of alcohol with thionyl chloride, and reaction of alkenes with halogen acids, it form organic of stable product by using the organic of rule. Preparation of haloalkanes from alkene, some free radical substitution chain reaction forming different types of substituted alkanes. In the Pfingsten reaction, the formation of one type of halogen from other type of halogen by using sodium iodide in the presence of sodium iodide and acetone. Schwarz reaction, the formation of fluoride from bromochlorohalogens. Hunziker reaction, where silver salt of fatty acids in the presence of bromine and carbon tetrachloride gives bromoethane. So these are all the methods of preparation of haloalkanes from alcohol, alkenes, and the conversion of one type of halide into other type of halide is Pfingsten reaction, Schwarz reaction and Hunziker reaction.